On October 19, 2017, astronomers in Hawaii made a remarkable discovery. While scanning the night sky, they spotted a faint, fast-moving point of light, an object unlike any seen before. It was moving so quickly and on such a strange trajectory that it immediately stood out from the countless asteroids and comets that regularly pass through our solar system. What made this object truly extraordinary was that it wasn't bound by the sun's gravity. It was a true interstellar visitor, passing briefly through our solar system before continuing on its journey through the galaxy. Its speed and path revealed that it had come from far beyond our solar neighborhood, making it the first known object of its kind. This was a historic first, proof that objects from other star systems can and do enter our cosmic neighborhood. The news spread rapidly, capturing the imagination of scientists and the public alike. For the first time, humanity had direct evidence that the vast distances between stars could be crossed by natural objects. The object was named Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. The name was chosen to honor the location of its discovery and to reflect the sense of mystery and anticipation that surrounded it. The name captured the sense of awe and the urgency that followed. Astronomers around the world realized they had only a brief window to observe this visitor before it disappeared forever into the depths of space. Oumuamua was already speeding away, moving so fast that every hour counted. The race was on to gather as much information as possible before it slipped beyond the reach of our telescopes. Telescopes worldwide scrambled to collect every possible bit of data before it vanished into the darkness. Observatories coordinated across continents, sharing findings and images in real time, united by the urgency of this fleeting opportunity. Each observation was a rare clue to its origin and nature. Scientists pored over the data, searching for any hint about where Oumuamua had come from, what it was made of, and how it had traveled such an immense distance. The discovery was more than a scientific milestone. It was a reminder that our solar system is part of a much larger galactic community. It challenged us to think beyond our own star and to imagine the countless worlds and objects drifting through the vastness of space. Oumuamua's arrival opened a new frontier, the study of interstellar objects. For the first time, astronomers could study something that had traveled from another star, carrying secrets from a distant corner of the galaxy. It challenged our assumptions about planetary systems and hinted at a galaxy filled with wandering messengers. If one interstellar object could find its way to us, how many more might be out there, waiting to be discovered? For the first time, we had tangible evidence that the universe sends us visitors. Each new observation brought more questions, fueling debates and inspiring new theories about the nature of these cosmic travelers. The race to understand Oumuamua was on, and the world watched as scientists tried to unlock its secrets. News outlets covered the story, and the public followed every new development with fascination. This single point of light would ignite debates about the nature of our place in the cosmos. Was Oumuamua a fragment of a distant planet, a piece of an ancient comet, or something even stranger? The story of Oumuamua is not just about discovery, it's about confronting the unknown. It's about the thrill of encountering something truly alien, and the humility that comes with realizing how much we still have to learn. It forced us to ask, what else is out there, waiting to be found? How many other messengers from distant stars have passed us by, unnoticed in the vastness of space? And what messages might these cosmic travelers carry? Oumuamua's brief visit reminds us that the universe is full of surprises, and that every discovery opens the door to new mysteries, waiting just beyond the edge of what we know. As data poured in from telescopes around the world, excitement and confusion grew among astronomers. Oumuamua proved to be a true anomaly, unlike anything ever observed before in our solar system. Its brightness changed by a factor of 10 as it spun, suggesting an extremely elongated or perhaps even flat shape, something never seen in any known asteroid or comet. Early depictions imagined a cosmic cigar, but the reality was even stranger, with some models proposing a pancake-like form. Its path was hyperbolic, confirming it came from beyond our solar system, making it the first known interstellar object to visit us. Moving at nearly 59,000 miles per hour, it was a high-speed interstellar traveler, racing through space faster than any object of its kind ever recorded. Unlike comets, Oumuamua showed no tail, no coma, and no outgassing, even after passing close to the sun, behavior that baffled scientists. It appeared dry and rocky, more like an asteroid, yet its shape and behavior didn't fit any known category, leaving experts puzzled. If it was an asteroid, why was it so elongated? Far more than any asteroid we've ever seen. If it was a comet, where was the tail, the gas, or the dust that should have been released as it neared the sun? Oumuamua defied classification, challenging our understanding of what's possible in the cosmos and forcing scientists to rethink what interstellar objects might be like. It was a mystery from the start, an object that didn't fit any box, drifting alone through the vast emptiness of space. Scientists were left with more questions than answers, debating theories late into the night and searching for clues in every scrap of data. The puzzle of Oumuamua had only just begun, and its secrets continue to inspire curiosity and wonder about what else might be out there, waiting to be discovered. The debate over Oumuamua's nature split the scientific community. Some argued it was a dry asteroid, perhaps a fragment from a shattered planet. Others insisted it must be a comet, with hidden ices or an insulating crust masking any outgassing. But these explanations felt forced, tailored to fit the data rather than emerging from established theories. I proposed a third idea. What if Oumuamua was artificial, an alien artifact, perhaps a solar sail? A thin, flat object would explain its light variations and strange acceleration. The idea met resistance. Many preferred natural explanations, citing Occam's razor. But when faced with a true anomaly, shouldn't we consider all possibilities? The debate continues, fueled by the object's baffling properties. Oumuamua remains an enigma, challenging us to think beyond the familiar. When astronomers first observed the dramatic changes in Oumuamua's brightness as it spun through space, they imagined a long, thin object, hence the nickname cosmic cigar. The way its light fluctuated suggested it was shaped like a giant, tumbling stogie, unlike anything seen before in our solar system. But as scientists dug deeper, analyzing the data from multiple telescopes, a new theory emerged. The evidence pointed toward a flat, pancake-like shape, something more like a cosmic frisbee than a cigar. This was a surprising twist that challenged initial assumptions. Statistically, a tumbling disk would produce the observed light curve far more often than a cigar-shaped object. The way the brightness changed matched what you'd expect from a flat, spinning object, not a long, narrow one. Yet, this led to a new puzzle. In nature, flat, disc-shaped rocks are extremely rare. Most asteroids and comets are lumpy, irregular, or roughly spherical. So how could such a thin, wide object form naturally in the harsh environment of space? And even if it did form, how could it survive a journey across interstellar space, battered by cosmic radiation and collisions with dust and gas? The odds seem stacked against such a fragile shape making it so far. The pancake model was as puzzling as the cigar, leaving astronomers scratching their heads and debating what forces could create such an object. But from an artificial perspective, a thin, flat shape suddenly made sense. It's exactly what engineers would design for a light sail, a spacecraft propelled by the gentle push of sunlight. Light sails use radiation pressure for propulsion, requiring a large, thin surface to catch the photons. This technology is already being tested here on Earth, and it's a leading idea for interstellar travel. If Oumuamua was a technological artifact, its unusual shape would make perfect sense, designed for efficiency, not for survival in nature. The mystery only deepened. Was this bizarre visitor a cosmic oddity, a fluke of nature, or could it be a piece of advanced engineering from another civilization? The debate over Oumuamua's true shape and origin only fueled the intrigue, keeping scientists and the public alike captivated by its cosmic enigma. The biggest surprise came after Oumuamua passed the sun. It was accelerating, pushed by an unknown force. Normally, comets accelerate due to outgassing, but telescopes found no evidence of gas, dust, or a tail. To explain the acceleration naturally, scientists had to invent new types of comets, ones we've never observed. These stealth comet theories felt increasingly contrived. The light sail hypothesis, however, offered a simple answer. A thin, flat object would be pushed by sunlight, matching the observed acceleration. The force decreased with distance from the sun, just as solar radiation pressure would predict. No outgassing, no tail, just a gentle push from photons. If Oumuamua was a light sail, the mystery wasn't a mystery at all. The acceleration became a clue, not a paradox. The case for an The idea that Oumuamua might be an alien artifact was too important to ignore. The Breakthrough Listen project aimed the Green Bank telescope at Oumuamua, searching for artificial radio signals. Billions of channels were scanned for any sign of technology. It was the first time we'd listened to an interstellar visitor for a message. The result? Silence, no artificial signals detected. Some saw this as evidence against the artifact hypothesis. But absence of evidence isn't evidence of absence. The object could be defunct, silent, or using technology we can't detect. The silence only deepened the mystery. Oumuamua left us with more questions than answers. Suggesting Oumuamua was artificial met resistance from mainstream science. There's a strong bias against ideas that seem speculative or sensational. Many scientists proposed exotic natural explanations, inventing new categories to avoid the alien hypothesis. Fear of ridicule and professional risk keeps bold ideas on the fringe. But science advances by challenging consensus, not clinging to comfort. We should define what evidence would support or refute artificial origins, not dismiss the idea outright. Oumuamua should have sparked open-minded investigation, not just creative natural theories. The episode highlights a need for more imagination in science. The search for truth demands we follow the evidence wherever it leads. Oumuamua's discovery transformed interstellar objects from theory to reality. It proved that debris from other star systems can reach us, opening a new window on the galaxy. Each visitor is a sample from another world, offering clues to planet formation and the ingredients for life. The mystery also pushes us to take the search for extraterrestrial intelligence seriously. If even a few interstellar objects are artifacts, we must be ready to detect and study them. Projects like the Vera Rubin Observatory will help us find more. Oumuamua reminds us how little we know and how much there is to discover. It challenges our assumptions and inspires new questions. The universe is full of surprises, and we must keep exploring with open minds. The journey to understand these messengers has only just begun. Oumuamua is gone, but its mystery endures. Was it a bizarre natural object or a relic of alien technology? The debate continues, fueled by the data it left behind. Its existence forces us to confront the question, are we alone? If we find more objects like it, the case for artificial origins grows. If not, we still learn about the universe's creativity. We must invest in technology and rapid response missions to study future visitors. The universe is sending messages. We need to listen. Oumuamua's legacy is a renewed sense of cosmic perspective and wonder. The search for answers has only just begun.